Hello and welcome back. Today we'll learn the basics of Boolean operations in CATIA. If you don't know already, Boolean operations are called like that after George Boole, an English mathematician who essentially invented a branch of algebra in 1854, later called Boolean algebra, that uses logical operators like AND, OR, NOT, and so on and so forth, and deals with binary values. This will later set the foundation for modern computing and circuit design. Looking at a visual representation of the logical operators, you can easily see the similarities to the add, remove, and intersect operations in CATIA. In fact, they are identical, so you understand why they are called the way they are. For today's examples, we will model this part, which I believe showcases the use of these operations. So take a good look at this part. I will post pictures of a drawing with some basic dimensions. You will probably not see all the dimensions here on the part because it's a very complex part. Okay, so take a good look because we will close this and create a new part. We will close this and to the file new command create a new part. Right. We will start by modeling the top surface. I'm going to fast forward a little bit while I draw the sketch because I assume you already know how to constrain sketches. We will be using the automatic snap features a lot. Alright, now that we have our base, we can extrude this. Let's just say for now we'll go 30 millimeters up and 30 millimeters down. Good. This looking like a plastic molded part. It does need to have draft angles on the walls. So for that we will use the draft feature. We select all the walls that we want to draft and we select the natural element. And then 5 degrees seems about right. We click preview and see the direction is good. And we click OK. Now we have drafts on this. Next, we will cut the shape on the top of the surface like we had before. We will put a sketch like this. It's actually a bit higher. It's 10 millimeters. And there you go. Now that we have our sketch, we can create a big pocket. We need to put a dimension here, like 100 and 100, to make sure it cuts everything. Alright, good. Now, alrighty. Now we will start adding radii. I know we said last time that maybe adding radii should be the last thing, but now I do have a plan for this, and you will see what it is in a minute. So we start applying the radii all over the surface. There you go. Now, to make this part hollow, we will use a feature called shell. You can find it here. You click on the surface you want it to disappear. Everything else will have basically walls with thickness, and you select here the thickness you want, default thickness, and then it's click OK, and you have basically an empty shell of what you draw. Good. Now that we have our first our base, so to say, for the part, we can go ahead and create a new body. Now this body is the one that will benefit from one of our Boolean commands, and this is one of the use cases I find very interesting for Boolean commands, is when you have one feature and you need to multiply it multiple times all over the part. So for this I will try to showcase a different feature as well, which is the shaft command, and we will draw one of those little bumps on the part, and then we will multiply it. We will translate that one over here as well. So to do that, we will create a sketch. At first, we need an axis for this. 60 millimeters away for this. Okay, good. Secondly, we need another sketch. And here we will draw our profile. Again, I will go a little faster doing this. This sketch needs to be basically half the section through the part, and it needs to be centered around the axis at which we started. Good. Now this needs to be a closed surface in order to work. We exit the sketch, we hit the shaft command, select our sketch as the profile and this as our axis. Make sure this is 360 degrees, and then we have this little cone. Right, now we're going to take care of the radii inside the cone. We can go ahead and hide our initial body, and we can work in isolation on this feature alone. This one inside radius is going to be 2 millimeters. This one is going to be 5. Good. Now we have our cone. We need to replicate this cone somewhere over here. So in order to do that, we choose the pattern, the rectangular pattern. Our direction is the X direction, and we are patterning the current solid, everything we have. So we need 2 instances, and then we just maybe 80 millimeters should be enough. And then we have our second cone here. Now, to use our Boolean operation in order to solve this. This is a perfect use to combine this shape. It's a very, very good use for the union trim operation. Now, this basically adds the two bodies together, but you also have the option to trim some of the edges. So you choose the union trim, and then you have to choose the second body. First, you have to be active in the body you want to as your base, and then you select the second body as your trimmed body. You select this, and it has some options here, but if you click OK, it's basically virtually the same as an add operation. You see, you have these little cones, and now it's just one single body. But if you want to select some faces to remove, you can select this and this, and it will remove them. But hold on, this is not right. We want a hole there. Well, of course, you can select this faces and this face as well. Click OK, and there you go. After this all acts like one body, and you can go ahead and add radii. where you need to. Alright, now let's go ahead and model the ribs inside, because we saw that there were some ribs in the part. We add another body to this. We make sure that we are in this active body, and we go ahead and make a sketch. Let's see. We will model the rib like this. 3mm thickness, and we will put it, let's say, something like this, 82mm from this line. We do need to constrain the sketch. It's always a good idea, even though it's the value is not important, but we don't want it to jump around. Now we make a rib like this. Perfect. And then we need to have it angled. We need a draft surface on this. Draft angle, sorry. This is probably going to be much smaller because we don't want a very thick rib at the base. This is not the direction we wanted to. So normally there's a little arrow, but you can also put minus 1.5 degrees here and click OK. Good. Now we'll pattern this. We need to reference the direction X, current solid, and this is fine. Something like this? No, it doesn't look right. We need to move this here and maybe something like that. It's probably not exactly the same, but for the sake of this this tutorial, we'll go with what we have here. Good. Now we have our second body. Now we need to use another Boolean command in order to join these together. Now this would be a great example to use the union trim. It'll work perfectly. But however, I don't necessarily want to do all these clicks on the screen because they are not really stable. If I ever decide to change anything, then I might have to click on the screen again. So let's say we don't want to use union trim for this. We want to use the add command. But first we need to trim the ribs. In order to do that, we create a geometrical set. And then we go over to the generative shape workbench. We extract the interior of this with tangent continuity. And then we switch back to our part design. Good. We go back to the ribs, and then we use the split command. The split splits our current solid with a surface, and we select this surface. We need to reverse these arrows in order to keep the inside of the surface, and click OK. We can go ahead and hide this. Now if we go to our part body, again, right click and define work object, we can use very simply the add command. So you see we click on the body 3, the latest one that contains the ribs, and we add the body 3 to our part body. Okay, that looks perfect. Now all we need to do is add a little cutout here in the bottom. So in order to do that with booleans, you can obviously do it with a simple pocket, but since we are discussing booleans, we are going to use this. So sorry, not like that. we will use this sketch. We will make a sketch on this plane, and we will use one of the existing sketches that we did for this pocket. With the sketch selected, you can click on project 3D element, and this sketch will project onto your latest one. Then you will offset this to, let's say, minus 13 millimeters. You will also need to put a line here. You will join the line through a radius like this, and you need to make this one a construction element, because this will have to be a closed surface, closed body, sorry. Good. Now we create a body like this. We would probably need a draft angle here, so we can do this with the draft command. What do we want to keep this one? Sorry, no. We want to keep this one as the natural element. This is probably too little. We need like something like minus 30 degrees. No, minus 25. Minus 20. I think that's more like it. And now, in order to remove this body from this one, we click on the part body and define it in work object, and we use the remove command. We first click on the object we want to remove, which is the body 4, our latest body, and we remove it from the part body. And here it shows you that it will be after the add 1 operation, which is the latest one. And we click OK. And there you go. After this, you can always apply radii wherever you want to make your parts feasible. Now, it does take a little while to add all the radii on these ribs. To be honest, it might have been better to do a lot of those features before doing the pattern. But this works pretty fine as an example. Now, as you can see, I've experienced some issues due to not having enough flanges on either side of the radii, but I managed to fix them. So with a little tweaking, I have managed to get this part, to get these ribs nice and round as we want them. The final touches will be obviously these ones and this ones. Good. Now, that pretty much covers all the Boolean operations except one. There's one that we have not talked about, which is the assemble one. I have put together a part to showcase this. So, the assemble operation is essentially an add, but will take into account the sign of the body. So, some bodies are positive signs and some bodies are negative signs. To show you this example, we have this body, which is a positive sign, the part body. I think this one has to be positive, which is a pad. It uses a pad command. Now, if the one of the bodies would only contain a pocket command, that would mean it would be a negative body. So if I had a empty body here and make a sketch in it, put a circle in and put a pocket inside this body and click OK, you would expect it to not do anything, right? Because we cannot put a hole through air. Well, wrong. In CATIA, this one will create a negative body. It creates the shape of the pocket, but it puts a minus sign here. So pockets and holes and grooves are negative operations, while pads and shafts and other stuff are positive operations. So if here instead of a pocket I would put a pad, then this would be a positive body, as you see here in the tree. This one doesn't have a sign because I think it has to be a positive body if it's the main one. Right, so what does the add do? When I click add, sorry, need to be in the part body, which is the green one, and I click the add operation, it will add the negative body to this one. So basically it'll automatically change the sign to plus. It'll treat it as a positive body. If I hit Ctrl Z and I do the assemble operation and assemble this negative body to my positive body, it will actually remove it. So that's the main difference between assemble and add. So assemble is an add that takes into account the sign of the body. So that's it for today. Thank you very much for watching. Please, if you haven't already, subscribe and like this video if you like to see more content like this. Thank you very much. Have a nice day.